So suppose, continuing here with some other types of problems, suppose you were asked to evaluate the tangent of cosine inverse of negative 12/13. Again, let's remember, this item right here, this is an angle. So the big picture is I'm looking at a tangent of an angle. It's an angle that has a cosine of negative 12/13. And since I'm dealing with cosine inverse, that angle has to be between 0 and pi. So for the cosine to be negative, that means I've got to be in the second quadrant, 0 to pi, cosine negative, be somewhere over here. And my cosine needs to be, for this angle, whatever it is, the cosine needs to be negative 12/13. So I create my triangles I've always done. Let this be negative 12. Let my radius of the circle here be 13. And then I'm looking at a 5 here. So I then can label the coordinates of this point to be negative 12, comma 5. And now I answer the question, what is the tangent of this angle? It's going to be y over x, or negative 5/12. So suppose we want to look at a function y equals cosine of cosine inverse of x, or y equals cosine inverse of cosine of x. We've got a composition of inverse functions, and in the past when we've looked at a composition of inverse functions, we said, well, if I do a function, I take my input, do a function to it, and then apply the inverse function to it, I'll get back and get the same thing. So it looks like I might have a whole bunch of ordered pairs x comma x coming out of here. Ditto over here, cosine and cosine inverse are inverse functions. I'm going to take the cosine of some angle, and then I'm going to undo from take the cosine of the angle. That gives me a trig ratio. What angle has that cosine? And I might say, hey, it looks like it's going to be a whole bunch of x comma x's. So let's take a look in a little more detail here for a minute. And we'll start actually with this one over here first. Over here, what's my domain for this function? In other words, if I'm going to put something in for x, what can I put in? And the answer is I can put in anything. Cosine of any angle now we know how to find. So my domain for this function is all reals. What's my range? Well, the range is going to be, once I've gone ahead and put in an angle here, whatever it is, I'm going to take its cosine, and then what am I going to do with that trig ratio? Cosine inverse says I'm looking for an angle from 0 to pi that has this value as its cosine. So my range, my outputs are only going to be then between 0 and pi. Let's take a look at domain and range for the first one now. First one in here, what's my domain? What can go in as an x value here? Well, it has to be a trig ratio. It's got to be the cosine of an angle. And the cosine we know is limited from negative 1 to 1. So my domain over here is going to be x has got to be between negative 1 and 1. Now, once I put that input value in, say it's root 2 over 2, the cosine inverse of root 2 over 2 will be pi over 4, picking an angle between 0 and pi that has a cosine of root 2 over 2. Then I take the cosine of pi over 4, and I get what I started with, root 2 over 2. So here then, I'm going to have my range be, my y values have got to be between negative 1 and 1. So, looking at this first graph here, we say, okay, what's this graph going to look like, the cosine of the cosine inverse of x? Whatever I plug in here, I will get my x has got to be a value somewhere between negative 1 and 1. I look for an angle that has that as a cosine. I then take the cosine of that angle. It's going to take me right back to where I started from. So indeed, I'm looking at y equals x from negative 1 to 1. So it'll be the portion of the line y equals x, but with a restricted domain. Now, for the second function, take your calculator if you want. Go ahead and load this one into your y equals, making sure that you're in radian mode, and see what the graph looks like, and see if you can make sense out of that graph, noting what you've got here, what our domain and range turned out to be, and see if that makes any sense. It might help you in doing that to consider something like putting in like x is 7 pi over 4 as you're looking at that graph. So if I put 7 pi over 4 into here, I'm looking at the cosine inverse. The cosine of 7 pi over 4. Cosine of 7 pi over 4 is root 2 over 2, fourth quadrant angle. Cosine inverse of root 2 over 2, I got to pick an angle between 0 and pi. So the angle between 0 and pi that has a cosine of root 2 over 2 is pi over 4. So I'm going to have 7 pi over 4, pi over 4 is a point on this graph up here. And note, that's different from x equals y that I got over here. So that might help you a little. So let's suppose we're going to look at where the arc notation, arc sine, arc tangent, arc cosine notangent comes from. This is problem number 10 out of section 7.6 homework problem, the second day on the inverse trig. And basically to help you get through that, I'm going to walk you through what they do in their paragraph. Let's suppose we got a unit circle, we got some angle in standard position on the unit circle so that our radius here is 1 and that angle subtends or cuts off an arc of length s. So by definition of radian measure, the radian measure theta is going to be s over r. In this case, s over r is s over 1. So theta equals s. So in other words, the cosine of theta, it actually, since s and theta are the same thing, is cosine of s. So let's suppose here in the unit circle, if I'm looking for the coordinates of this point up here, I'm going to come over x and up y. So let's say the cosine of s is x over 1, or x. If we look at our inverse then, we know we switch our two coordinates. So the cosine inverse of x equals s, and that makes good sense. It says that x is the cosine of some angle, so we're looking for an angle. In cosine inverse case, we're looking for an angle between 0 and pi such that the cosine of that angle is x, and that angle will be theta, or s. And if we then look at this for a bit, s is an arc here. It's an arc in the unit circle, but it is an arc. So if I read this aloud, really what I'm looking for, this s is the arc on the unit circle, s, of an angle whose cosine is x. We're looking for the arc on the unit circle, s, whose cosine is x. And then if I simply say, well, let me shorten that little sentence down, let's just call that then arc cosine of x equals s. And that's where the arc sine, arc tangent, arc sine idea came up. These, again, these two notations mean exactly the same thing, and they're interchangeable.